So we want to find the inverse of this function, and that means we want to find the function that does the inverse operations of the original function. So we need to figure out what operations are being done to the input in the original function, and then undo all those operations. So for example, say we plugged in a number for x in the original function, so let's say 2. So that means we would find 2 to the 2 minus 5 plus 4. And so the operations that we would do first we would subtract the 5. If we were simplifying this, we would make this 2 to the negative 3 plus 4. And then we would do the 2 to the negative 3. We would do the power part. 2 to the negative 3 is 1/8. And then we would add the 4 at the very end. So 1/8 plus 4, 4 and 1/8. So I'm just going to list the operations that we just did. When you input a number in the function, the first thing we did is subtract 5. And then we did 2 to the power that we just got when we subtracted 5. So we got negative 3 when we subtracted 5. And then we did 2 to the power of negative 3. And then the last step after doing the power was adding 4. So I add 4. All right, so for the inverse function, we want to write the equation for the inverse function that would undo all of those operations. So we work backwards, and the operation that would undo adding 4 would be subtract 4. That's the inverse operation. And then the operation that undoes a power with a base of 2 is a log with a base of 2. So we would take log base 2 of whatever we have so far. Actually, I'm just going to go ahead and start building the function. I'm going to start writing what we have so far. So for our inverse function, we want to take the input and subtract 4. I'm just leaving some space so we can add more things to it. Subtract 4, so I did that. And then we want to do the log base 2 of whatever we have so far, log base 2 of that. And then the last operation we need to undo is subtracting 5, so we would add 5. So I'm going to do that to the equation that we have so far, add 5. So if you plugged in a number for x into this function that we just wrote, just making sure it follows these operations, you would plug in a number, you would subtract 4, you would take the log base 2 of that number, and then add 5. This is our inverse equation. So we're going to try now this. If we plugged in a number into this function, we would do base 1/2 to the power of that number. That would be the very first operation being done. And then we would multiply by 3, and then subtract 1. So these are the operations being done in the original function. So we want to write what needs to be done for the inverse function. So we want to undo these operations. The inverse function is the function that undoes all these operations, does the inverse of all these operations. So the inverse of subtracting 1 is add 1. And I'm going to go ahead and start writing the equation. So for the inverse function, we want to take the input and add 1. I'm just leaving some room in case I want to build more on top of that. All right, so we took care of subtracting 1, and then we want to undo, we're working backwards, so now we want to undo the step of multiplying by 3, which would be divide by 3. So I'm going to take the x plus 1, divide by 3. And then we want to undo the operation of a base of 1/2 to a power, which is log base 1/2 of whatever we have so far. So then I'm going to do log base 1/2 of the whole thing we have so far. And that's our inverse equation, or inverse function. So if you notice on the last one, we started with an exponential function. We ended with a log function. Another one where we're starting with a log, and that means we want to end up with an exponential function, because exponential functions and log functions are inverses. All right, so I'm going to list the operations done in this function h of x. So if I plugged in a number for x, I would subtract 3, and then take the log base 4 of whatever number I have so far when I subtract 3, and the last step would be subtract 10. All right, so now I'm going to write the steps for the inverse function. The inverse of subtracting 10 would be add 10. I'm going to go ahead and start writing the equation as I'm writing down the steps. So for the inverse of h of x, we would take an input, we would add 10. Okay, I just got rid of subtracting 10, so now I want to do one step back and do the inverse of log base 4 of some number. And the inverse of that is a power with a base of 4 to whatever we have so far, 4 to that power. So far we have x plus 10, so then I would do 4 to the power of x plus 10. And then the last step I want to undo, so we did subtract 10, we did undoing log base 4. Now we want to do the inverse of subtracting 3, which is add 3. So I would take the function I have so far and put a plus 3. I'm just going to move this h, the inverse of h of x, down a little more so this looks a little better. So the inverse of h of x is 4 to the power of x plus 10 plus 3. And we're going to do one more with a natural log. So natural log is log base e, so we're going to need to know that when we undo the natural log. So I'm going to write the steps being done to k of x. So if I put in a number for x, the first thing I would do to that number is add 5. Then I would do the natural log of whatever I have so far after I add 5, and then divide by 2. All right, so here's my steps for the inverse function. I want to undo dividing by 2, which would be the inverse of dividing by 2 would be multiply by 2. I'm going to start writing what I have so far. The inverse of k of x. We want to take the input and multiply it by 2, so I'm going to put just 2x, that's what we have so far. So I undid the dividing by 2, now I want to undo the natural log of something, and the inverse of taking a natural log is a power with the same base as the log. Natural log is base e, so e to some power. So far I have 2x, so now I want to do e to the 2x, e to the 2x. So we did the inverse of natural log of some number, and then now we want to do the inverse of adding 5, which is subtract 5. So I'm going to take what I have so far and just add a minus 5. I'm going to move the inverse of k of x down so this looks a little better. So the inverse of k of x is e to the 2x minus 5.